All right, this is a challenge video on factoring special cases in our unit on polynomials and factoring. I encourage you to pause this video, try these on your own, and then follow along and see how you did. So the first one, the one on the left, is a difference of 2 fourth powers. Yikes, so we know how to work with a difference of 2 squares. How do we work with a difference of 2 fourth powers? So, let's rewrite it. Let's call this 9x squared minus 625. So look what we just did. We just turned it into a difference of 2 squares. 625 is a perfect square. It's 25 squared. And then the first term was a perfect square as well. So this is going to turn into 9x squared plus 25 times 9x squared minus 25. Okay, we just followed the difference of 2 squares rule. Now we need to think, are we done? Could we go any farther? Well, this is still a square, or a difference of 2 squares. So we can't do anything else with the left term, but we can factor that right-hand term, 3x plus 5 and 3x minus 5. All right, so we just factored a difference of 2 fourth powers by basically turning the fourth powers into perfect squares of already squared powers. All right, let's do the next one, which I think is going to be a little more involved. A square patio has an area of that, and a second patio has an area of that. Find the difference in area by factoring each expression, subtracting, and then factoring some more. Okay, so let's factor each expression first, and they both look like perfect squares. Neither of them looks like a difference of 2 squares. They both look like perfect squares. Let's try to color coordinate a little bit. So we have yellow and orange, and let's do the yellow guy first. So that's going to turn into 3x minus 5 squared. Right, and let's make sure that checks out. 3x squared plus 25. Yep, that checks out once I FOIL it out. Now the orange is going to be over here. That turns into 4x plus 7 squared. And does that give us the 56 that we need? It does. 7 times 4 doubled gives us 56. So we need to find the difference in area between those two patios. So we're going to do a big subtraction. So check this out. Now we have a difference of 2 squares, right? This is a square, this is a square, and that's a difference. So we have a difference of 2 squares. So this is going to turn into, let's see, 3x minus 5 plus 4x plus 7 times 3x minus 5 minus 4x plus 7. And I'm going to, since we're doing a subtraction, I'm going to make sure we put that in parentheses. Okay, let's keep going. I don't know where this is going to end up, but it looks like it's working kind of okay so far. So we have a 7x plus 2. And then the right-hand side is 3x minus 4x is a minus x minus 12. Okay, so now I can FOIL those guys. I guess I'm a little unsure about how far we need to go. So I'm going to consider what we have is a reasonable answer, but let's go ahead and FOIL them out as well and just see what we get. I'm curious. So the first 2 terms are minus 7x squared. The outer 2 terms, 12 times 7, 84. So we have a minus 84x. Inner 2 terms are minus 2x and minus 24. So minus 7x squared minus 86x minus 24. So I think both of these are legit answers. So here is the quadratic trinomial, and here is the factored form of that. And hopefully you can see we could have gotten the quadratic trinomial just by subtracting these guys up here, okay? 16x squared subtracted away from 9x squared, that's what gives us the minus 7x squared down below. So I'm going to consider my final answer to be this one because I thought that was a nice fully factored form of representing the difference in area of those two patios. All right, that's a good place to stop right there.